The indefinite integral does not have limits of integration. No limits of integration. Another property, the answer is a function. Actually, to be exact, is a family of functions. In parentheses, not a number. The indefinite integral does not have limits of integration. And the answer is not a number. And the answer will be a family of functions. So here's a simple example. The indefinite integral from x squared dx. It's the same thing with the most general antiderivative. Same thing with the most general antiderivative. So the integral from x squared dx is that's why the answer is a family of functions, because c can be any real number. So there is an infinitely many family of infinitely many functions that have the same derivative. One other property that we did not encounter so far, it's very important, the third one, we can check indefinite integrals. We can always check the answer. Always. For indefinite integrals, we can always check the answer, which we could not for definite integrals. Okay, how do I do it? Fundamental Theorem of Calculus Part 1 tells us how to do it. What do I have on the left-hand side when I differentiate the integral? This takes care of this. What is left? Let's differentiate this side. What do we get? Bring down 3, simplify. What is left? Differentiate c. So indefinite integrals, we can always check the answer. It will only take a blink. But definite integrals, we cannot. Let's practice. Okay. On page 404. Let's start with number 12. The integral from x squared plus 1 plus 1 over x squared plus 1 dx. This is an indefinite integral. The answer will not be a number. The answer will be a family of functions, the most general antiderivative of the given function. And if I want to, I can always check. So, ready? Please tell me what to write. Plus? Excellent. Plus? But arctangent. Plus? That's it. Can I check? Sure. If I differentiate the right-hand side, I will get x squared. I will get plus 1. I will get plus 1 over x squared plus 1. And c prime is 0. Okay, next one. Let's look at 14. The integral from cosecant squared t minus 2e to t dt. Cosecant squared t minus 2e to t. Don't forget that Monday we review for the test from chapter 4. Please bring that form that I gave you so we can, and I will come up with more problems the entire time on Monday. We'll review for the test. So please finish up everything because I will select some problems from where we're assigned. Please. Chapter 4. Okay, ready? Which function prime is cosecant squared? Yes, but negative. Cotangent prime is negative cosecant squared. Good. Minus 2 e to t plus c. Very good. Not too much. What about 16? The integral from secant t times secant t plus tangent t dt. We don't know how to integrate products. We have to distribute. So secant t, in parentheses, secant t plus tangent t dt. So what should I write first? Secant squared t plus secant tangent. And now I'm ready. Which function prime is secant squared? Very good. Plus, which function prime is secant tangent? Just secant t plus a constant c. Any questions? Any questions on indefinite integrals? Any questions on indefinite integrals? Okay. Do you think we should look for other problems? Yes? Very good. Awesome. Let's look at more problems like number 9. Same page, 404. The integral from u plus 4 in parentheses times 2u plus 1 du. Again, we don't know how to differentiate, to integrate a product. So we have to distribute. So let's distribute. The integral from 2u squared plus 8u plus u and plus 4. Do we accept this? We have to combine like terms now. Let's combine like terms. Two u squared plus 9u plus 4. Very good. Awesome. And then what do we have? 2 over 3 plus 9 over 2 plus, this is it, This is the family of functions. The family of functions whose derivative is this, or better, this. Ready for the next step? Yes? Like with any substitution, if it makes our life easier, it's worth it. If it doesn't make our life easier, then we should not use it. So that's the purpose of the substitution rule. Yes, we will treat the definite and indefinite integrals differently. Allow me to show you a couple of problems from each, and then we'll continue practicing. Problem 9 on page 413. The integral from 1 minus 2x raised to the 9th power dx. This is, I'm just showing you the easiest way to remember this, not the scientific way, just the easiest way for now. I'm looking at this function and I see a binomial to the 9th power. If I were to raise this to the 9th power, I would have 10 terms. And then I will integrate 10 terms. I don't want to do that. And I say to myself, is there a possibility for me to change that? And say, give me any variable, not x. Z. My z is kind of weird. Just choose another letter. Which one? U. Very good. So let u be 1 minus 2x. So I'm changing the function by denoting. I'm not changing it, but I'm denoting the function by u. Then look what happens. This will be much nicer, right? To have u to the 9th power. But I'm running into a difficulty. I cannot have in an integral, a single integral, u and x. So I have to do something about this. I cannot have u dx. I have to have u du. So therefore, if you remember, we differentiated between f prime of x and y, dy, which is f prime of x dx. So here I have u, but I need in an integral with u, if I have f of u, I need times du. So I'm given this function, or we created this function, but I need to find du. So tell me how to write du for this function. Is the function prime? What do I get? Negative 2 times du. So the substitution works as long as I can create du, or du is in the problem, or with a minor change that I can handle. And the minor change that I can handle is very easy to handle, is the negative 2. Yes, please.
Du equals negative 2 times du, or du times dx?
Of course, I'm sorry. I'm already thinking of the next step. My apologies, of course. So it's f prime of x dx, of course. Sorry, my apologies. This is the function. So it's f prime of x dx. Thank you. Thank you. So I was going to get in trouble when I put it in right now. So I do have dx, but I don't have negative 2. It's not a problem to multiply and divide by negative 2. This is 1. Negative 2 and negative 2. But here's what I accomplished with that. This is the du, and this is u to the 9th power. So therefore, I have negative 1/2 in front. Let's see what happens again. U to the 9th power du. And this is much nicer. And the answer is negative 1/2. What function prime is u to the 9th? U to the 10th over 10 plus a constant c, or negative 1 over 20 u to the 10th plus a constant c. This is awesome, but I cannot give the answer in u. An answer in u is not acceptable. So I have to go back and replace u with what I used, or what I replaced, u minus 2x. So 1 minus 2x is u. I have to go back and put it back in. That's not a difficult problem or situation at all. I will go back and I will give the final answer as negative 1 over 20, 1 minus 2x to the 10th power plus c. Using the substitution, it really helped us determine the integral. It's an indefinite integral. If you have any doubts, what will you do? Check. Just differentiate and see if you get 1 minus 2x, everything to the 9th power. Let's check. So this is our answer. We want to differentiate this, and let's see what we get. It's negative 1 over 20. We bring down 10. We subtract 1 from the power, and we differentiate the inner function. But negative 2 times 10 is negative 20. Negative 20, these will all go away, and the answer is indeed what I started with. So this is always easy to go back and check. The result gets differentiated, and I go back and see if I get the starting point, and we did. So the substitution rule is a powerful tool that enables us to determine these integrals. Ready for the next? Okay, 16. On 413. The integral from e to the x, we're still talking about the indefinite. Cosine e to the x dx. I look at this function, e to the x times cosine e to the x, and I say, well, I don't really like e to the x inside cosine. I don't. It's a function composition. It's difficult to deal with. So then I'll say, what if I denote what by what? Yes, indeed. That is the problem. What if I denote by y, e to the x, but I need to find dy? How much is dy? It's not the derivative, it's a differential, please. Excellent. No problem. Look at this. I have dy. So the integral easily changes into, remember I cannot have x and y in the same integral. Once I change from x, everything changes into y. So what do I have? So I do have cosine, yes, times, indeed. Much easier to handle. Which function prime is cosine y? Very good. Sine y plus a constant c, not enough. Good, but not enough. What do I have to do next? Yes, sine e to the x plus a constant c, and that's final. Okay, any questions on this? 20. The integral from z squared over z cubed plus 1 dz. Let's think of a substitution for this problem. Also have in mind, number one, something that you would like to get rid of. That's number one. Number two, that you don't really like, it's inside of another function. If you could take that away, it would make your life easier. Secondly, you have to think in terms of the substitution. When I find the differential has to be inside the integral. Because if you say denote z by cosine, I will not be able to. It's not the proper substitution. Because I don't have cosine prime in the problem. And I can make up cosine or sine. I can make up a -2. I can make up a 4. But I can make up an x or a z or sine t or cosine z. Okay? So two things in mind. One, something that bothers you, that it's inside another function and you would like it to go away, if possible. Secondly, when you define the dy or dt or whatever you want to use, whatever variable you want to use, or you want to denote the function by, it has to be in the problem quite easily. Good. Please tell me what you think you would like to make it disappear. And then I'll tell you what I would like to make it disappear. Say it again. Say it again. I didn't hear. Well, I would like us to discuss because that's how we learn.
Like z squared over z? Oh, no, never mind. Not like.
Anyone else? What do you think? I'll tell you what I don't like, but I wanted to hear from you first if you'd like to say anything. I don't know if it's possible first, but I know I can tell you immediately what I don't like. I don't like two terms in the denominator because I can never simplify those. I don't like a sum in the denominator or a difference in the denominator. I don't. Because I can't simplify. So I'm going to say let u be z cubed plus 1, but only if du is in the problem. If du is not in the problem, then it's not the right substitution. So what is du for z cubed plus 1? Not enough. Not enough. This is we're not differentiating. We're finding the derivative, the differential. Yes. Is this in the problem? Of course it is. That's what I want. It is in the problem with some minor change, but I don't have any problem. I can always create and make up numbers, but I can create sine, z, t, whatever. So now can anyone give us the new integral with 1/3 in front?
Z squared over
There is no more z. We're done with z. du over?
u.
Exactly. So remember, when you change from z to u, there is no more z. You have to carefully replace each and every piece in terms of u. Perfect. And this I know. We just discussed it a few minutes ago. What is this? Which function prime is 1 over u? Very good. Of absolute value. Crucial. So natural log of the absolute value of u plus a constant c. Although this is good, however, it's not good enough. What do I have to do now, finally?
Plug it back in.
Yes. I'm trying to put that link in there, and look what I'm getting. What is this?
You look at
Why, I just logged in back in a second ago. Again,
it. Is the site itself working properly?
I don't know. I just logged in 3 times because I want to put the link because I got. Never mind. Sorry about that. I just want to upload the next video, so that's why I wanted to put the link in, but it won't let me. Okay, so 1/3 natural log of the absolute value of z cubed plus 1 plus a constant c. Is this clear?
Yes.
Okay, let's look at more. 22. The integral from cosine to the 4th theta times sine theta d theta. This is basically the first technique of integration. When you move on to Calc 2, you will learn way more. Trig substitutions, you will learn integration by parts, and so much more. But this is our first technique of integration, substitution rule. Okay, so let's take a look. What do you think? What don't you like here? Right, I don't like that. It's a cosine, it's a function raised to a power. Of course, I don't like that. So I'm going to say, let y be cosine theta. Only if what is in the problem?
Sine theta.
Only if dy, which is the differential of y, which is,
Sine theta.
careful, negative sine theta, that's not enough.
D theta.
Very good. It is in the problem. No problem. Just have to multiply by -1 twice. And now this piece with this piece is dy. So the answer will have a minus in front. And now remember, once we moved from theta to y, there is no more theta. So what do I write? Y to the 4th. That's okay. U or y is the same thing. If you use u, don't change to y. It's not a problem.
Minus D times negative.
The negative times sine times d theta is dy. All we have left is y to the 4th. So then minus what? However, this is good, but not good enough. Yes, cosine to the 5th over 5 plus a constant c. Any questions? Do we understand the idea? Remember, we cannot change a function into another function if we do not have the differential of the new function in there. Okay? Good. Next one. Yes? Okay. Bless you. 24. We have the square root, the integral from the square root, sine, in parentheses, 1 plus x raised to 3/2 dx. And I think that you're getting the hang of what's happening here and what is the proper substitution. Okay, so I have the square of x, and I have sine of blah and dx. I don't want to see anything like that inside sine. It pokes me in the eye. So then, what will you do or say or write? UB, right. Good, so this appears to be the right substitution, but if du is not in the problem, then we have to go back to the drawing board. Good, so give me the differential of u, please. Right, very good, which is the square of x.
dx.
Excellent. I have it. As long as I put the 3/2 and the 2/3 in front, 2/3 times 3/2 is 1. And I found my du. Oops. Du, it's u. And then what is this? Okay, just tell me what to write. Careful, this 3/2 is already incorporated with the square of x and dx. 1, 2, 3 pieces are in du. Yes, the integral from sine u du. Do you prefer sine u du, or you prefer the square of x sine of 1 plus? Right? Good. So now I want to find the antiderivative. Which function prime is sine u? Negative cosine u plus a constant c. Good, but not good enough. Because the integral was given in x, the answer must be in x. So all we have to do now, just write cosine in parentheses 1 plus x to 3/2 plus a constant c. Is this okay so far? Okay. Let's look at 40. Notice that we have not gotten, and I'm not going to present today, the substitution rule for definite integrals. I think we are okay with just this for now. So 40. The integral from, and we still have some loose ends here and there before we finish this chapter. 1 plus cosine squared x dx. We had a similar problem before, and I said, I'm bothered by the denominator. But if I use the substitution, 1 plus cosine squared x, it's not going to work. Because I have 2 cosine times negative sine. So I haven't accomplished much, because I can't make the cosine at the top. So let me write what I just said. So in the previous example about 10 minutes ago, we said that z cubed plus 1 was t, or whatever, u. So if I do this here, do not write this, or if you want, you can. It's up to you. If you use this, then du will be 2 cosine x times negative sine x times dx. I can make the cosine at the top. I have the sine, I have the dx, I can make up the 2, but I can make this one up. So this is not working in this case. But what is working in this case is let u be some function whose derivative is up there. Which function? I don't have the derivative of sine. Yes, indeed. Just cosine x. So then du, the differential of u, equals Not enough dx. So now I go back to the problem, to the integral, and here's what I see. I have no difficulty with this. Multiplying by -1 twice. And this is our du. And the denominator can be replaced by what?
1 plus d squared.
Wonderful. And this I know. What is it? Exactly. Arc tangent u plus a constant c, but now I have to go back and replace. What am I replacing it? Arc tangent.
Closest.
Very good. Awesome. Plus c. Great job. Okay, 34, and then we can stop if you want. So 34. So it's just the substitution rule for the indefinite integrals. 34. The integral from cosine pi over x divided by x squared dx. So in the numerator, cosine pi over x, and in the denominator, x squared. Okay. What don't you like here? Pi over x. I don't like pi over x. I like cosine, but I don't like pi over x. So I will say let u be pi over x, as long as du is in the problem. That's the reason why I insisted, please try to remember the derivative of 1 over x. What is it? Right, negative pi over x squared. Awesome. Not enough times dx. Okay, so I have the x squared. I have the dx in the numerator. The only thing I'm missing is negative pi. No worries. I can always multiply the top by negative pi and multiply the denominator by negative pi without making any, without changing anything. So now careful. The negative pi with the dx and with the x squared in the denominator. Of course, another method will be to solve for dx. If it's easier for you to solve for dx, you can. It's the same thing. Okay? So negative pi times dx over x squared, all these form du. There is a -1 over pi in front. And can anyone dictate the integral now? Nice, right? So the answer will be -1 over pi. Which function prime is cosine? Sine. Of course, plus a constant c because it's an indefinite integral. And we have to finish with replacing u by pi over x. So -1 over pi sine pi over x plus a constant c. Of course, you can always go back and check. If you differentiate this, you have to get that. Let's do it just for this one. So let's differentiate. I have -1 over pi. Sine prime is cosine pi over x times the inner function prime, which is negative pi over x squared, times c prime, which is plus c prime, which is 0. So this will go away with this, the negative with the negative. So we have cosine pi over x squared. Cosine pi over x squared. So remember that the